The fungus among us, fungals and FunGuys. Scientists have discovered that the trees in a forest can give each other food and moisture by sharing through the fungal network. Get it? Fungal, fungal. According to Dr. Elaine Ingham, the world-renowned soil microbiologist, the soil biota forms the soil food web, where plants give and receive nutrients together with soil biota according to nature's design. Plants and animals utilize soil for food and shelter, disturbing the upper soil layers and transporting chemically weathered rock called saprolite from the lower depths up to the surface. Bacteria convert atmospheric nitrogen to plant available forms, and mycorrhizal fungi grow extensively through the soil in long strands that form networks between the tree roots, like an underground internet, sending nutrients and water from the earth in exchange for carbohydrate energy from the trees that absorb sunlight. And everybody wins. If you look down in the description box below, you'll see a diagram called the soil food web, and you can see how from the soil, all kinds of life forms get their food. And you can imagine that ultimately at the end of it, we would be on a higher level. So take a look at that diagram. It's quite interesting. It will help you understand the value of keeping your soil healthy. So you can see here, even pocket gophers play a role in increasing net plant growth by churning nutrients, aerating soil, and throwing rocks or trash up to the surface. For instance, we had a gopher up by the street, or up in our yard by the street, that cleaned up an area that had chunks of old asphalt embedded in it and left fluffy soil instead. But there's more. The underground fungal web allows trees to communicate with each other too. In 1997, Suzanne Simard, professor of forest ecology at the University of British Columbia, found one of the first pieces of evidence. She showed that Douglas fir and paper birch trees could transfer carbon between themselves via mycelia, which are the fungal threads. They look different from the mushrooms that we see popping up, but underneath the ground, there's these filaments called mycelia that are the fungus, one of the growth patterns. So the Douglas fir and the paper birch trees could transfer carbon between themselves via the mycelia, and other people have shown that plants can exchange nitrogen and phosphorus by the same route. Suzanne Simard believes that large trees help small younger ones using the fungal internet. Without this help, she thinks many seedlings wouldn't survive. In the 1997 study, seedlings in the shade, likely to be short of food, got more carbon from donor trees. So there is evidence that the trees interact with each other, trying to help each other survive. Scientists have discovered that 1 teaspoon of rich soil, such as forest soil, can contain 1 billion microscopic bacteria, yards of fungal filaments, thousands of protozoa and nematodes, which of course would have to be very tiny to all fit into a teaspoon. The fungal internet exemplifies one of the great lessons of the food forest. Biodiverse organisms are united and depend on each other for survival. And here's some food for thought. Earth is amazingly, beautifully designed to sustain perpetual life and harmonious yet complex balance.